Hello, I'm gonna present imitation learning for simultaneous escape routing. And I'm Minsu Kim. I'm MS candidate of KAIST, advised by Professor Jung Kim. Recently, reinforcement learning based methods are making considerable attentions for not only dynamic control system but also design optimization tasks. In this year, Google Brain proposed a novel reinforcement learning method for TPU chip placement. Current research proof of RL-based hardware design drawing on remarkable attentions that RL is applied to PDN optimization, channel routing, equalizer design in our communities. RL is beneficial because we can exclude human expertise, domain knowledge. Therefore, we can automate design procedure of hardware. RL has two main phases. Firstly, in training phase, the policy solves the problem to get a solution. Then, the solution is evaluated by simulator. Then the reward is evaluated and is used for training the policy. The reward can be anything related with electrical performances. It can be bandwidth or it can be eye-opening for signal integrity. After training finishes with multiple iterations, the trained policy can solve a new problem in the real world. It can optimize hardware with fast time. Let me introduce reinforcement learning more detail. We can decompose the training phase of reinforcement learning into two pieces again. The training phase are decomposed by data collecting phase and training phase. In the data collecting phase, Policy Explorer to make data for finding which action is beneficial to make good reward. The collected data is used for updating policy. Usually in recent researches, policy is often parameterized by deep neural networks. Therefore, we can train policy by gradient descent scheme with the collected data. Because policy is not perfect to collect data, but the policy evolves for each iterations, we must iterate data collecting phase and training phase many times, which means the simulator must evaluate the quality of produced solution many times. The simulation procedure for hardware design is often time-consuming. Some people use even 3D EM solver for signal integrity evaluation. Therefore, RL-based method is inefficient to hardware design in terms of massive simulation processes. Then let me introduce the replacement method, the imitation learning, which is main topic of this research. Imitation learning is very similar with reinforcement learning. Therefore, some people just state that imitation learning is kind of reinforcement learning. The main difference is that imitation learning collects data with expert policy. The expert policy is constant, not a variable. Therefore, we do not have to iterate data collecting phase and training phase. The expert policy can be human or other promising algorithms such as genetic algorithm. The important point is that the trained policy can overcome expert policy after training by policy exploitation. Imitation learning is new trend of nowadays machine learning model. For example, AlphaGo is evolved to AlphaZero and MuZero by imitation learning. The main benefit of imitation learning is sample efficiency. For us, hardware engineer, reducing the number of simulation is equals to sample efficiency. Because we can erase the iteration, the total simulation number is dramatically reduced. Then, let me introduce our target task, the simultaneous escape routing. The objective of escape routing is to maximize number of nets escaped from chip. Simultaneous escape routing considers two facing chips, unlike escape routing considers just single chips. In simultaneous escape routing, assigning net order is mostly important task. If wrong ordering is produced, these three nets can be escaped. If correct ordering is produced, all nets can be escaped. And this is main pipeline of our method. The solution or action is selecting the net order. Firstly, the expert policy make guiding solution. So the expert policy is random search algorithm. It selects the best solution among 100 random samples. Then each solution is evaluated by simulator. Our simulator is sequential A-star algorithm. The A-star algorithm finds shortest passes. The sequential A-star algorithm sequentially finds shortest passes based on the net order produced by the expert policy. After this data collecting phase is finished, the policy, which is parameterized by the transformer network, is trained by the collected data. We note that the transformer network, which is often used as language model, which is promising for sequential processes. That's why we choose it as our trainable policy. And this is training results. Imitation learning based method runs the policy extremely faster than reinforcement learning based method, which means it is sample efficient. Imitation learning based method trains the policy within 1 day, while reinforcement learning based method cannot finish the training even in 5 days. And this is performance evaluation result. The imitation learning based method outperforms several baselines, including the expert policy. Reinforcement learning based method could not train the policy effectively. Therefore, the performance of the policy is worse than other meta-heuristic methods such as random search and genetic algorithms. We note that every evaluations are fairly processes, that we set the same number of iteration or samples for these algorithms. Because every algorithm can produce an optimal solution if they can sample infinitely many samples. So that's why we just set 100 samples of each algorithm for fair evaluation. we applied the proposed method into 2D PC of Olympus CPU server board. The proposed method performs almost similar with human expertise routing on 2D PC of Olympus server board. To conclude, in simultaneous escape routing tasks, the imitation learning-based method can outperform reinforcement learning and genetic algorithm. Imitation learning-based method can replace conventional reinforcement learning researches on hardware design because it can reduce the number of simulations very efficiently. Thank you for listening, and any questions is recommended.